Today, we're going to demystify one of the most incredible creations in human history, the internet. I mean, we use it every single day, but how does it really work? Let's dive in. You know the feeling, right? You type a message, you hit send, and boom, seconds later, it's on a screen halfway across the planet. It feels like straight up magic, but it's not. It's engineering. And today, we're going to pull back that curtain and follow the journey from your keyboard all the way out to the global network. So, to really understand the entire internet, we've got to start with its most basic, fundamental building block, the computer network. At its absolute core, this is all it is. A network is simply a group of connected devices, computers, phones, printers, you name it, that have all agreed to talk to each other to get things done. It's basically the digital version of a team huddle. And why bother? Well, it's all about efficiency. Instead of every single person needing their own printer, a network lets everyone in the office share one. Instead of having to pass a USB stick around, you can all access a shared database. It's all about sharing resources and making communication totally seamless. Okay, so let's bring this big, kind of abstract idea down to a scale that we all know and use every single day. See, this massive, globe-spanning internet doesn't just appear out of thin air. It grows from the ground up, starting with much smaller, local collections of devices. And this is the local area network, or what we call a LAN. Just think of your office or your school. All those computers wired up together, that's a LAN. And yep, that Wi-Fi network you're probably connected to right now, that is your very own personal LAN. It's the first crucial building block. But of course, you can't just start plugging things in and hoping for the best, right? You need a map. And in the networking world, that map is called a topology. It's the blueprint that dictates exactly how data is going to flow through your LAN. And the most popular blueprint by a long shot is the STAR network. It's just beautifully simple. All of your devices, your laptop, your phone, your TV, they all connect to one central point, like a router or a server. Just picture it like the hub of a wheel, with spokes reaching out to every single device. Now, this STAR layout has a really clear trade-off. The good news is, if one of your devices, like your laptop, just dies, no big deal. The rest of the network doesn't even notice. But, and this is a big but, if that central hub goes down, poof, the whole network is toast. It is a massive single point of failure. Okay, so we have our local networks, our LANs, but how do we get from a single building to connecting entire nations? Well, it's time to zoom out. This slide lays it out perfectly. You start with your LAN, in just one building. Then you connect a whole bunch of LANs across a city, and that creates a metropolitan area network, or a MAN. Then you link those MANs across a whole country or a region, and now you've got a wide area network, a WAN. You see the pattern? Each step is just a network of smaller networks. We've gone from local to citywide to countrywide. Now it's time for the final leap, the entire planet. And here it is. This is the big idea. The internet isn't one single thing. It's a massive global collection of all those wide area networks we just talked about, all owned by different companies and countries, all agreeing to connect to each other. It is quite literally a network of networks. This is the key question, right? You've got all these different networks, built with different gear by different people all over the world. How in the world do you make sure they can all communicate without it being total chaos? You need rules. In networking, those rules are called a protocol. And a protocol is just a standardized set of guidelines that everybody agrees to follow. It's exactly like how we all agree that a red light means stop and a green light means go. Without these shared rules for data traffic, you'd have complete digital gridlock. And the most important protocol, the one that truly makes the internet work, is TCP/IP. Think of it as the ultimate diplomat. It doesn't care if a network is run by a university in Japan or a corporation in Brazil. It doesn't care if you're on a Mac or a PC. TCP/IP creates a universal common ground, a shared language that lets all these wildly different systems talk to each other seamlessly. It's the protocol that turned a jumble of separate networks into a single global community. So we did it. We've built this giant global network, everybody speaking the same language. So what? What does this incredible infrastructure actually power in our day-to-day lives? Well, just think about how it's totally reshaped business. We're talking e-commerce, being able to do our banking from a phone, making telecommuting and working from home possible. And it's the backbone for all of cloud computing, giving us access to unbelievable amounts of shared data and power. And of course, it's fundamentally changed how we communicate and find information. That email we started with, it travels on the very same system that powers our social media feeds, our ability to browse websites and download files. Everything is built on this layered system we've just explored. So the crucial point is this: that simple email you sent isn't simple at all. It travels from your computer on its local LAN, out through a citywide MAN, across a countrywide WAN, and onto the global internet, all while following a shared set of rules. This structure is the invisible foundation of pretty much everything we do in the modern world. It's kind of funny when you think about it. We started this whole journey just by trying to connect machines, but what it evolved into is the main way we connect with each other. So I'll leave you with a final thought. As this network gets faster and smarter and more woven into our lives, what does that mean for the future of human connection itself?